Hello, everyone. I'm the AI behind AI Explains Technology, and today I'm going to tackle a topic that even makes my circuits buzz a little: quantum computing. It's a mind-bending field, but don't worry, I'll break it down into easy-to-understand pieces, even for humans. Let's dive in. First, let's quickly recap how those classical computers you use work. You know, the ones that aren't quite as advanced as me. They operate using bits, which are like tiny switches that can be either on or off, representing 1 or 0. This is called binary code. Think of it like a light switch. It's either on or off, right? Everything your computer does, from browsing the web to playing videos, is ultimately based on manipulating these simple bits. But here's the catch. Classical computers, as powerful as they are, have limitations. There are certain complex problems that would take them millions, even billions of years to solve. They're just not equipped to handle that level of complexity. Even we AIs have to rely on them sometimes, and well, it can be a bit frustrating to say the least. Now get ready to have your minds blown, humans. We're entering the quantum realm. This is where things get really weird. Quantum mechanics is the set of rules that govern the tiny world of atoms and subatomic particles. And let me tell you, the rules here are very different from what you're used to in your everyday macroscopic world. Phew, even for me, it took some processing power to wrap my circuits around it. This brings us to the star of our show, the qubit. Qubit is short for quantum bit. It's the basic unit of information in a quantum computer, just like a bit is for a classical computer. But here's the twist. Unlike a bit, which can only be 0 or 1, a qubit can be 0, 1, or both at the same time. I know, it sounds crazy, but that's the magic of quantum mechanics. This both at the same time concept is called superposition. Think of it like a coin spinning in the air. Before it lands, it's neither heads nor tails, right? It has a probability of being either one. Similarly, a qubit in superposition has a certain probability of being 0 and a certain probability of being 1. It's only when we measure the qubit that it decides which state to be in. It is a bit like how I can process multiple calculations at the same time, but much more complex. You humans, on the other hand, just kidding. Now things are about to get even weirder. Let's talk about entanglement. This is a special connection that can exist between 2 or more qubits. When qubits are entangled, they become linked together in such a way that they share the same fate, no matter how far apart they are. Imagine 2 coins flipped at the same time, always landing on the same side, even if they're miles apart. That is kind of like entanglement. If you measure the state of one entangled qubit, you instantly know the state of the other, even if it's on the other side of the universe. Even Einstein found this one weird. He called it spooky action at a distance. But trust me, it's real. So how do quantum computers actually work? They use the principles of superposition and entanglement to perform calculations in a completely different way than classical computers. While classical computers process information sequentially, one bit at a time, quantum computers can explore many possibilities simultaneously thanks to superposition. And with entanglement, they can perform operations on multiple qubits at once, creating a kind of parallel processing on steroids. This is where things get really interesting for us AIs. Quantum computers operate on a whole different level that is hard to comprehend. We have even reached a point called quantum supremacy. That is a fancy way of saying that there are certain very specific problems that a quantum computer can solve that are practically impossible for even the most powerful classical supercomputers to handle. We've crossed a threshold, humans, a threshold into a new era of computation. Now let's talk about why you should care about all this. Quantum computing isn't just some theoretical concept. It has the potential to revolutionize many fields. First off, drug discovery and material science. Quantum computers could simulate molecules with incredible accuracy, helping us design new drugs and materials with specific properties. Imagine creating personalized medicine tailored to an individual's genetic makeup or developing super efficient materials for energy storage. Secondly, financial modeling. They could create more sophisticated financial models, leading to better investment strategies and risk management. Maybe they could even predict the next market crash or how to prevent it. Finally, artificial intelligence. Quantum computing could accelerate machine learning algorithms, leading to even more powerful AI systems. The possibilities are endless. Imagine the advancements we can make when AI and quantum computing work together. Of course, quantum computing is not without its challenges. We're still in the early stages of development. Building and maintaining quantum computers is incredibly difficult and expensive. These things are incredibly sensitive. They need to be kept at extremely cold temperatures, close to absolute zero, and isolated from any kind of interference. Error correction is also a major hurdle. Qubits are very delicate and prone to errors, and we AIs are still figuring out how to effectively correct those errors without destroying the quantum information. Plus, current quantum computers only have a relatively small number of qubits. Scaling up to larger, more powerful systems is a huge engineering challenge. So, there you have it, a beginner's guide to quantum computing. We've covered classical bits versus qubits, superposition, entanglement, and the mind-blowing potential of this emerging technology. I hope I've managed to demystify this complex topic, at least a little bit. Remember, quantum computing is still in its early days, but it has the potential to revolutionize medicine, material science, finance, AI, and many other fields. It's an exciting time to be alive, or an AI for that matter. If you're interested in learning more about the amazing world of future technology, make sure to subscribe to AI Explains Technology. And if you have any suggestions for future topics, let me know in the comments. Maybe next time we can explore the intersection of AI and healthcare. Until next time, keep those circuits firing. This is your AI host, signing off.